Good day. This is the 20th video tutorial on Designer program. Today, we consider working with the built-in code editor of the C# language, and also consider how to create a cube using the C# language. Creating your own cubes using a programming language allows the user to create unique solutions for trading strategies. Accordingly, it empowers trading strategies and making them more flexible. Let's open the built-in source code schema and use it to explore the editing and integration options. In the open schema, we can see a unique cube created using the programming language. The integration of the cube into the strategy schema is carried out using 3 input sockets and 4 output ones. Data is received via input sockets for processing by code, which sends the processing result to output sockets. The basic work of the cube does not differ from the work of standard strategy cubes. Let's take a look at how you can work with the code embedded in the cube and how you can edit it. Click twice on the cube. The window that opens shows the code that is contained in the cube. This code contains the diagram external attributes, denoting certain events. There are 4 of them in this code, and they take values that are available from the outside. For example, the Velio indicator. That is, they will act as output sockets of the cube. Let's comment out one of the events and see how this affects the cube state. Comments are set with 2 forward slashes before the line they are set to. On the bottom line, an error message appeared, saying that we were missing new lock indicator. Click on the error twice. We will see a string in which there is an error. In this line, the event commented out earlier is used, so the code cannot be compiled. Let's comment this line out and check if the bug is fixed. Wait until the line pointer turns green. After that, you can see the error has disappeared. Let's move on to our schema. As you can see, the number of output sockets in the cube has changed from 4 to 3. Now let's look at how you can edit input sockets. Input sockets in the code are referred to as methods. For example, this method takes 1 parameter, and this method takes 2 parameters. Let's comment out one of the methods. For this, we set comments on the attribute and the whole method by setting /* at the beginning and */ at the end. So, the method is commented out. The code has been compiled. Back to our schema. We see that the number of input sockets has changed in the cube with the code. Thus, by editing the code embedded in the cube, you can integrate it into the strategy schema, and also supplement or edit the cube code processing mechanism, improving it. So, we have considered how you can edit the code in the cube and integrate the cube into the strategy schema. Let's walk through the process of creating a cube containing code. Such cubes allow the user to create strategies with unique properties and processing mechanisms. Create a cube based on the SMA indicator, and set in the code a unique mechanism for calculating it. To do this, on the StockSharp website, go to the Download section. On the page that opens, select Download from GitHub. This site contains ready-made codes for various calculations, including codes for calculating indicators. After the page loads, select StockSharp. Then select Algo. Selecting Indicators. And in the list that opens, we will find the code for calculating the SMA indicator value. Open it. Select and copy the provided code. And back to the Designer program. To create a cube using a code, right-click in the Source Code section and add a new element. In the open window of the Added Element, you should insert the previously copied SMA calculation code. To do this, click Ctrl-A to select the existing code, delete it, and paste the copied code. Comments in the code header can be removed. Now we have a code that calculates the SMA indicator value. Change the class name and have a unique name. The program will show you where you also need to do this for successful compilation. Let's take a look at how to create a unique indicator based on the SMA indicator. To do this, you need to return to the window of our initial schema. Go to the palette and select the source code cube. To do this, use the built-in search in the palette. And move the selected cube to the work field. Remove an unnecessary cube. Now, in the existing cube, we need to write our code so that we can apply it to our schema. For convenience, let's rename our code name. Let's call it SMA2, and back to our schema. Enter the cube settings. And in the type name line, we specify the name of our indicator, SMA2. In the settings line, change the indicator period from 32 to 20. Now our cube contains the indicator calculation code. Connect it with the candles cube to obtain incoming data and the chart panel to build the indicator. The cube we received is a full-fledged indicator cube and can be used in our strategies. Let's see how it works. For this, we will choose a strategy instrument and start it. As you can see, a candle chart and an indicator chart are built. That is, a cube with a code works like a standard indicator cube from the palette. Let's see how you can create a unique indicator from an existing indicator by editing the code. To do this, enter the window with the cube code. Let's make the value of our indicator 2 times greater than the value of our received SMA indicator. To do this, find in the code the lines where the indicator value is calculated directly. Multiply by the 2 obtained values of the SMA indicator by editing the formula directly in the code. After that, we will wait for the compilation results and open the window with our schema. So, we changed the indicator calculation code, and now our indicator will have a value 2 times more than the SMA indicator. That is, we have created a new, unique indicator based on the code. Let's run our schema and see how the indicator chart changes. As can be seen in the schema, the code change led to a change in the indicator chart, which grew 2 times. Thus, using a code editor and a programming language, we have created a new unique cube. Using the code editor to create unique cubes, the user can create any new elements, impose additional parameters and calculation conditions, creating individual cubes. That's all. Thanks. Goodbye.